Welcome to this module, where we will delve into advanced topics in the MERN stack. We'll explore file uploads, third-party API integrations, and real-time communication capabilities. Now, let us begin by understanding file uploads and how to handle various media in your applications. This section focuses on empowering your MERN applications with rich media capabilities for a better user experience. File uploads are crucial for allowing users to add content, like images, to your applications. This feature enables the integration of diverse media types, including images, videos, and various documents. You can seamlessly integrate images, videos, and documents, enhancing the functionality and richness of your application. Let us look at some common applications where file uploads are essential for user interaction. This includes user profile pictures, which personalize accounts, and product images for e-commerce listings. Other uses include secure document storage and efficient video streaming within your application. However, there are some key challenges to address when implementing file upload functionalities in your projects. These challenges include validating various file types and sizes to maintain system integrity and performance. Additionally, storing files efficiently and securely is crucial to protect user data and ensure privacy. We also need to consider handling large file uploads effectively to prevent performance issues and ensure a smooth user experience. Let's now set up file uploads using Multer, a popular middleware for Node.js applications. We will configure the Node.js backend specifically for multi-part form data, which is essential for file uploads. First, we need to install essential packages that will facilitate file handling and other backend operations. You will install Express, Multer, Cors.nb, and Mongoose using the npm install command. Next, we configure Multer to specify the storage destination for uploaded files and how their file names will be generated. This code sets up Multer's disk storage, defining the uploads directory as the destination and generating unique file names. Finally, you need to create the local directory, where all your uploaded files will be stored on the server. The mkdir uploads command creates the designated folder in your project to store the incoming files. Now, let's dive into the Multer backend implementation, seeing how the configuration and upload route work together. We'll examine the specific code snippets for configuring storage and setting up the API route to handle file uploads. Here, we have the Multer configuration, which is foundational for managing how files are received and stored. The multer.disk storage function configures where files are stored and how they are named. Destination sets the folder, and file name generates a unique name. This code sets up Multer storage logic, defines the static file serving route, and initializes Express and Cors. Next, let us define the file upload API route, which will be responsible for processing incoming file requests. This post route uses upload.singleFile to process a single file upload. It checks if a file exists and returns its path or an error message. This code defines the post route for handling single file uploads and their responses, listening on port 5000. Moving on, let's explore how to store file metadata securely in MongoDB using Mongoose schemas. We will define a Mongoose schema for file information and then update the upload route to save this metadata. Here, we have the Mongoose file schema, which outlines the structure for storing details about each uploaded file. The file schema defines the structure for storing file information in MongoDB. It includes file name, file path, file type, and upload date. This code defines the Mongoose schema, outlining the structure for storing file-related information in the database. Now, let's create a route to fetch and display the files, retrieving their metadata from the MongoDB database. This GET route retrieves all file documents from the MongoDB database. It handles potential errors during the data fetching process. This code defines a GET route to fetch all file entries stored in your MongoDB database. Next, we will discuss third-party API integration, which allows us to extend our MERN applications. This means enhancing your MERN applications with powerful functionalities provided by various external services. The Google Maps API is a popular example, allowing you to embed interactive maps directly into your application. This API enables you to display locations on interactive maps, providing rich geographical context to users. For handling payments, the Stripe or PayPal API allows you to integrate secure transaction processing. These APIs are essential for processing secure online payments within your application, ensuring smooth transactions. The Open Weather API is excellent for fetching real-time weather updates, integrating dynamic weather information. This API allows you to fetch real-time weather updates, providing current and forecast weather data to users. Furthermore, the Twilio API provides robust capabilities for sending automated SMS notifications to users. You can use this API to send automated SMS notifications, improving communication and user engagement. Lastly, OAuth APIs such as Google or Facebook facilitate social media user authentication for easy sign-ins. These APIs enable social media user authentication, simplifying the login process for your application users. Let's now explore how to fetch external API data directly within our Node.js backend. We will focus on creating an express route specifically designed to interact with a third-party API. Here we have the external API route, which demonstrates how to integrate with an external service. This express route fetches weather data for a given city using Axios. It constructs the API URL with the city and a predefined API key. This code defines an express route that uses Axios to retrieve weather information for a specified city. We now move on to real-time communication using WebSockets, a powerful feature for modern web applications. This section focuses on enabling instant data exchange using Socket.io within your MERN stack applications. Real-time communication refers to the instant exchange of information between clients and servers without delay. This instant data updates between clients and servers are absolutely essential for dynamic and interactive apps today. Real-time communication is indeed essential for building dynamic and interactive applications that respond instantly. Let us consider some common use cases where real-time communication truly shines and enhances user experience. These include chat applications, offering instant messaging and live notifications for immediate user alerts. Other applications involve live streaming of content and collaborative apps where multiple users interact simultaneously. Now, you might wonder why we specifically choose Socket.io for implementing real-time communication. Well, Socket.io provides bidirectional communication, allowing both the server and client to send and receive data. It also offers very low latency, which ensures that real-time updates are delivered almost instantaneously. Furthermore, Socket.io boasts easy integration with both Express.js and React, simplifying development. Let's proceed with implementing the Socket.io backend. Setting up our WebSocket server. Our goal is to set up a WebSocket server that can efficiently broadcast messages to all connected clients. Here, we have the WebSocket server setup, which is the initial step for enabling real-time features. This code sets up an HTTP server and integrates Socket.io to enable WebSocket communication. CORS is configured for front-end access. This code initializes an HTTP server and integrates Socket.io, enabling real-time communication with CORS. Next, we will handle the socket events, which define how our server reacts to client connections and messages. The io.onConnection event listens for new clients. Messages received via the message event are then broadcast to all connected clients. This code handles new client connections and broadcasts incoming messages to all connected users. Let's now review payment gateway integration, providing an overview of popular options. We will compare Stripe and Razorpay to help you choose the best solution for your MERN applications. First, let us look at Stripe, a widely recognized payment gateway for various applications. Stripe is highly flexible, supporting multiple currencies, which makes it suitable for international transactions. It also supports a wide range of payment methods, including cards, digital wallets, and various bank transfers. Stripe is known for its simple and durable integration, offering developer-friendly tools and extensive documentation. Now, let us consider Razorpay, another prominent payment gateway, particularly popular in specific regions. Razorpay is best suited for Indian currency, INR, transactions and is widely used within India. It supports various local payment methods like cards, UPI, digital wallets, and net banking options. Razorpay is very popular in India, offering robust support for UPI and other local payment solutions. To conclude, let's summarize the key takeaways from our discussion on advanced MERN development topics. These are the essential points and insights you should remember for building sophisticated MERN applications. Firstly, remember that Multer is the go-to middleware for handling file uploads efficiently in Express.js. Secondly, files can be stored either locally on your server or more robustly on cloud services like Cloudinary. Thirdly, file metadata such as name and path is typically stored in MongoDB using Mongo schemas. Fourthly, third-party APIs are crucial for extending functionality, covering payments, weather, and authentication. Fifthly, Socket.io is indispensable for enabling real-time communication, perfect for chat and notifications. Finally, payment gateways like Stripe and Razorpay are vital for securely processing all your online transactions.